In 10.4, we're going to be looking at graphing the quadratic functions. The objective that you are writing down says, I will be able to graph quadratic functions given tables of values and be able to identify the x and y intercepts. This is similar to what we did in 10.3 when we had our introduction, but we're going to get a little more involved in this section. When you're done with your objective, go ahead and move on. The very first thing that we need to understand is being able to find the vertex. When we look at any kind of parabola, whether it's open facing like this one, or it is downward facing like this one, the vertex is the turning point. For example, in this first parabola, it is falling down until this point right here where it begins to move up. So this point right here, which is the lowest point of the parabola, is its vertex. Looking at the downward facing parabola, if you notice it's rising up, and then at this point it stops going up and it begins to come down. This point is the vertex. So when we are talking about finding the vertex, I just want us to visually understand what we're doing. Now, in order to find the vertex, we have this formula right here that says x is equal to negative b over 2a. Just a quick reminder, when we look at this first equation, y equals x squared plus 8x plus 7, remember that there's really a 1 understood to be in front of the x squared, so our a is 1, our b is the 8 that is on the x, the coefficient, and our c is the 7. So when we go to find the vertex, we're going to say x is equal to negative, and then we'll sub in the 8 for our b, all over 2 times a. Well, a is 1. So if we simplify the fraction, we will have negative 8 on top, 2 on the bottom, and negative 4. So we know that the vertex occurs when the x-coordinate is negative 4. But if you remember, anytime we write the coordinates of a point, we have an x-coordinate and a y-coordinate. We have our x, we now need to find our y. So take a moment and think, do we have an equation anywhere that tells us how to find y? Right there. We have that y is equal to x squared plus 8 times x plus 7. We found x to be negative 4, so we're going to sub in negative 4 wherever there was an x. Using order of operations, we are going to do exponents first. If we have two negative 4s, negative 4 times negative 4 is positive 16. We will then continue and multiply the 8 times the negative 4 next, which is negative 32. So we will have 16 minus 32 plus 7. If we continue solving, 16 minus 32 is negative 16. Negative 16 plus 7 is negative 9. So now that we have that y value of negative 9, we now know the vertex of this parabola occurs at the point negative 4, 9. That is going to become very important because that's going to be one of the first points that you want to find when you are asked to graph a quadratic function. So here's the little bit of notes that we're actually going to write down before we begin practicing. The graph for a quadratic formula is called a parabola, and it is shaped like a U. A parabola can be open-facing, upward-facing, or downward-facing. The quadratics can be written in 3 different forms. You can see it in standard form, like ax squared plus bx plus c. So for example, y equals 2x squared plus 3x plus 4. That is one form we can find it in. Another form is the factored form, which you may have seen previously, where y is equal to, and then you've got the two things, the binomials that have already been factored, like x plus 3 and x minus 2. The third one that we're going to touch on a little bit today, but a lot more in our next section, is vertex form. When you see it in y equals a times the quantity, x minus h all squared, plus k. We will learn exactly what the a stands for, the h, and the k. The beautiful thing about vertex form is once you know what each letter stands for, it basically gives you the directions of how to graph it, just like y equals mx plus b did last semester. Okay, so here's our first example. It is in standard form, so we have y equals, or f of x equals, x squared plus 6x plus 8. You will see with different problems, sometimes we will give you x values, and then you will sub them in and find their coordinating y points. Sometimes it'll be blank, and you get to pick your own points. You'll notice down here on the bottom, I have 3 things that I would like to do. The first one is I'd like to find the vertex. So using that formula that we just saw, x is equal to negative b over 2a. Remind yourself that a is 1, b is the 6, and c is 8. So negative b would be a negative from the formula and then the 6 over 2a, which is 2 times 1. That is negative 6 over 2. So the x-coordinate is at negative 6 divided by 2, which is negative 3. So that is this point right here. When x is negative 3, as soon as we find this y-coordinate, we will have found the vertex. Well, the original function said f of x equals, which is the same as y equals. We're going to do y equals x squared plus 6x plus 8. We found that x was negative 3, so we're going to go ahead and sub that negative 3 in wherever there was an x. Negative 3 squared is 2 negative 3s, so negative 3 times negative 3 is a positive 9. 6 times negative 3 is negative 18, and then we'll add our 8. So 9 minus 8 is negative 9. Negative 9 plus 8 is negative 1. So the vertex occurs at the point negative 3, negative 1. So if I come over here to my graph and I graph the vertex, it is right here at negative 3, negative 1. Make sure you have that work down because I'm going to go ahead and erase it so I have room to find our x-intercepts. All right, so now let's go ahead and find our x-intercepts. If you remember in our previous section, we would take the trinomial and we would set it equal to 0 and see if we can factor it. So if I have x squared plus 6x plus 8, I need to find the 2 numbers that multiply to 8, and the same 2 numbers must add to 6. That is 2 times 4 and 2 plus 4. That gives me the 2 binomials x plus 2 and x plus 4. That is why we spent plenty of time learning how to factor in our factoring unit. We set each one of those equal to 0, and when we solve it, we will do minus 2 on both sides, and we'll end up with x equals negative 2. And then over here, we will subtract 4 from both sides, and we'll end up with x equals negative 4. So the 2 x-intercepts occur at negative 2, 0, and at negative 4, 0. So here are those points, negative 4, 0, negative 2, 0. So I'm going to go ahead and graph those points, negative 2, 0, and negative 4, 0. Take a moment, make sure you have those down as your x-intercepts. Now the next one, so we have found our vertex and our x-intercepts. Now let's find the y-intercept. Remember, the y-intercept is simply the constant on the end. It is 8. So it occurs at the point 0, 8. So there is another point that we can graph, 0, 8. So we're looking pretty good. I'm hoping you can kind of see the shape the parabola is going to make. One thing I would like to point out is when we found that x equals negative 3, that was our vertex, the blue dot, we can imagine an imaginary line going here that divides our parabola in half. Here's why we like knowing that. This green point is 1, 2, 3 steps away. So if I want to mirror image that, I would go 1, 2, 3 steps away, and I can get its coordinating point. So if we take a moment and look, and we connect our points, we can see that we have an open-facing parabola. So we found the vertex, we found the x-intercepts, and we found the y-intercepts. And we did find when x was negative 1, it looks like we're right about here. So that is -1, +3. So take a moment. That's a lot to take in, but we did take time to find the x-intercepts, the vertex, and the y-intercept. Those are the steps and the points that we need to find for each quadratic function. When you feel you have the table and the graph done, and you've labeled the x-intercepts and the y-intercept, you can go ahead and move on to the next example. Notice this equation is in factored form. That means the trinomial has already been factored into its forms. Here's why we like that. We're going to take each one of the factors and we're going to set them equal to 0, just like we did in 10.2. When we do our one-step equation, we're going to add 4 to both sides, and we get x equals 4. So our first intercept is located at 4, 0. Our second intercept, when we add 2 to both sides, is located where x equals 2. So that is the point 2, 0, because the x-intercepts occur on the x-axis, meaning y is 0. So if I were to graph those 2 points, we are on the x-line at 2 and 4. That's going to be a pretty narrow parabola. So the good news is we found the x-intercepts super quick. Now, to find the y-intercept, though, this needs to be in standard form. So I'm going to multiply or distribute. If you are a box person, this is where you would want to draw your box. If I continue distributing, we would end up with x squared minus 6x plus 8. We need to be in standard form in order to be able to steal the y-intercept right there. It occurs at 0, 8. So if I were to graph that point, that is right here at 0, 8. I'm going to make it yellow just so we can see it. So now we have found the x-intercepts and the y-intercept. The question now is, where's the vertex? Is it a high point or a low point? And where is it located? Do you remember the formula that we need to find that? In the beginning of the notes, we wrote x is equal to negative b over 2a. So we have negative, and here's our b, negative 6, over 2 times a, and a is the number on the x squared, which is 1. So we will have negative 6 over 2. That means it occurs where x is negative 3. Now there's no point on our table where x is negative 3, so we're just going to go ahead and add it right over here. Now I need to find its missing y-coordinate, and then I can graph it. Well, we know x is 3. I can either sub it into the factored form or the standard form. I'm personally going to go with the factored form. Y is equal to x minus 4 times x minus 2. We know that x was negative 3, so I'm going to sub that in. Negative 3 minus 4 is negative 7. Negative 3 minus 2 is negative 5. When I multiply those, my y-intercept occurs at positive 35. Excuse me, that is not our y-intercept. That is the y-coordinate of our vertex. I apologize for the vocabulary there. So there we go. The y-coordinate of the vertex is at negative 3, positive 5. Okay, I'm going to stop right there and see if anybody caught on to my error as you were watching the video. When we were finding the x-coordinate in green, did you see my mistake? The formula says x is equal to negative b over 2a. Well, here's the negative from the formula, but there's also a negative 6. Well, a negative times a negative should have been a positive 6, which means this is a positive 3. So if I sub in a positive 3, 3 minus 4 is negative 1, and 3 minus 2 is positive 1, so that is negative 1. That makes a lot more sense visually with our graph. So that occurs when x is positive 3, y is negative 1. So this is our vertex right here, 3, -1. And generally, once we found that x was 3, it should be right in the middle with that imaginary line in between those x-intercepts. So when I got a -3, I should have questioned that, because there is no way the vertex would be over here at -3. So now we have our x-intercepts in red, our vertex in blue, and our y-intercept in yellow. Let's get one more point. This yellow y-intercept is 1, 2, 3 steps away from the imaginary line. So let's go 1, 2, 3 steps away on the other side of the line of symmetry. So now when I go to connect my points, I have my parabola. If you have any questions, take a moment, look back at the problem, make sure when you find the x for the vertex that it is a +3. When you are ready to move on, go ahead. If you are using the paper copy of the notes, you can go ahead and cross this question off. If you are writing it as you watch it, just skip on past this slide to the next one. Here we go. We have a blank table. This is the way I prefer it. We're going to make up our own x values. Remember, I said the very first thing we want to find is the vertex. So we're going to use x equals -b over 2a. So let's watch our signs carefully this time. We have a negative, but then I'm subbing in a -4 over 2 times 1. Make sure you see that the 1 is the a, the -4 is the b, the -5 is the c. We're not using the -5 because the c is not needed for this part of the formula. So a negative times a negative makes a +4. 4 over 2 equals 2. So the very first point that I'm finding is where x is 2. This is my vertex. This is a crucial, important point that we find. We know that x is +2. Now I need to sub that in to find the y value. So when we see f of x equals, that's the same as y equals. So we have y equals, there's my 2 squared, -4 times 2, -5. 2 squared is 4, -4 times 2 is -8. 4 minus 8 is -4. -4 minus 5 is -9. So the vertex occurs at the point 2, -9, just slightly off of my graph. And that's okay. Remember, once we find this vertex, I can picture an imaginary line going right through it straight up vertically that's going to cut my parabola in half. Now let's go ahead and find the x-intercepts next. Well, the x-intercepts occur when we factor this trinomial. So if I have two numbers that multiply to -5, and those same two numbers add to -4, I will be able to easily factor that. I'm going to go with x minus 5 times x plus 1. If I set each one of those equal to 0, I can easily find my x-intercepts. So if I add 5 to both sides, I will get x equals a +5, because 5 minus 5 is 0. So that's 1.50. And the other intercept, if I subtract the 1, I will end up with x equals -1. So the other x-intercept is at -1, 0. So I'm going to go ahead and graph those points, 1, 2, 3, 4, 5, and -1, 0. Notice they are equidistant. They are the same distance from that imaginary yellow line. So I have my vertex, and I have my two x-intercepts. I could actually go ahead and sketch an idea of the parabola, knowing that it's going to look something close to this, but it's not as exact as I could be. So let's go ahead and take a moment and find another point. There we go, putting that other x-intercept back on there. There we go. Let's find the y-intercept. That's an easy point to steal. That is right here. The y-intercept is the c, it is the constant. That occurs when x is 0, so 0, negative 5. 1, 2, 3, 4, 5. Let's see, 2, negative 9. Here we go. If I go ahead and steal my symmetric point, that yellow point, the y-intercept, is 2 steps away. So if I go 2 steps away in the other direction, I can find its mirror image point. Now, I can be a little more accurate when I am connecting my dots. And there is my parabola. We found the x-intercepts in green at the point 5, 0 and negative 1, 0. And we found the y-intercept at the point 0, negative 5. Take a moment, make sure you're good, that you're able to find the vertex, the x-intercept, and we found the y-intercept. If you're feeling comfortable with that one, go ahead and move on. If not, if you want to re-watch it, go ahead and watch it again without having to write it all down and see if it makes a little more sense. Once you get to this point in the notes, I would like you to stop if you are in regular algebra. We're going to break this video into 2 sets of notes. If you are taking this video as an honor student, you are going to continue 10.4 because now we're going to look at vertex form. So now we're going to continue graphing the quadratics from the third type of form called vertex form. So the objective, if you are starting a new set of notes, would be that you're able to graph from vertex form using the tables, and we will continue describing characteristics such as the minimum and maximum, the h and the k shifts, which I'll explain in just a moment, and we will go back to the domain and range concepts again. Here's an example of what vertex form might look like. And if you see the example down below, so as I explain it in terms of a formula, you can visualize the one on the bottom. If we see that f of x is equal to, we might have a number outside parentheses, and then in parentheses we'd have x minus another number, all squared, and then there'll be plus a constant or another number on the outside. What is beautiful about this form, and what makes graphing so easy if it's in vertex form, is we can steal the vertex right from it. We take whatever the number is inside the parentheses, and we take the opposite of that number, and that is the x-coordinate of our vertex, and the constant on the end is the y-coordinate of the vertex. So for example, yes, I'd like you to write this down. If we were to simply find the vertex from this equation, we would take the opposite of what's in the parentheses, which would be a negative 2, and then the constant on the end would be the y-coordinate, positive 3. So the vertex is located at the point negative 2, 3. So now let's look closely and make sure we've written that down. What does each one of these numbers mean? The number outside the parentheses, which is the a, that represents how the graph is reflected. If a is positive, it will open up. It will be a happy parabola. If a is negative, it will open down. It will be a sad parabola. And yes, we will be using those terms, happy and sad parabolas. Inside the parentheses, that number tells us how the parabola transforms or translates left or right. If the number inside the parentheses is a minus and then the h, that's actually a positive number and it will go left. If it's a negative number, it will go right. Because remember I said we're going to take the opposite of what the number is. And then the number on the end, the constant, the k, that tells us how it goes up or down for its transformation. When I'm talking about left and right and up and down, here's what I'm comparing. The parent function for any quadratic formula has the vertex sitting at the origin. Anytime a parabola sits right at the origin with its vertex, that's the original parent function before we move it up and down or left and right. If we see something in vertex form where something's been subtracted in parentheses or added on the end, that means it has moved from that parent function location. So let's take a moment and look at our first one. It just is the parent function, y equals x squared. Notice the a, or the number on the x squared, the coefficient, is a 1 that is positive. So because this is a positive 1, that means our parabola opens up. The vertex is located at x is equal to negative b over 2a, just like we've been practicing. However, because it is only x squared and nothing else has been added to it, we know the vertex is for the parent function. It is located at the origin 0, 0. Because my parabola is opening up, that means the vertex is the lowest point before the parabola begins to move up. So that is a minimum value. Is it being shifted left and right? Well, there is no number. It is not in the factored vertex form, so it is not moving left or right, and it is not being shifted up or down because there's no y equals x squared plus a constant on the end. Because there is no constant, it is not being moved up or down. The domain and the range. If we were to simply sketch the parabola, we have our vertex at the origin, and we could get a pretty quick idea of about what the parabola looks like. We could sketch and estimate. The domain, from left to right, it's going from negative infinity to positive infinity. As far as how low it goes, it's going as low as 0 and as high as infinity. Domain and range is something we've been doing all the way since August. Make sure you're good because y equals x squared is the easiest parent function to graph. In the next couple examples, you'll see it in vertex form where we are shifting that parent function. This example, if you're following on the worksheet notes, I want you to cross it off because I already have one very similar to it that we're going to do. Here's where I would like us to start. We have y equals x minus 3 all squared. Because there is no constant being added on the end, I'm going to visually put a 0 there. Notice it is positive. If we were to multiply x minus 3 times x minus 3, we would end up with x squared, and that is a positive x squared. So that means our parabola is opening up. So let's go ahead, and because it's in vertex form, let's go ahead and steal the vertex. Remember, we take the opposite of the number in parentheses. That's a negative 3, so we'll take the opposite, and then we steal the constant on the end for the y coordinate. That means our vertex is located at the point 3, 0. Is that a minimum or a maximum? Well, if my parabola is open facing up, that means that is the lowest point before the graph begins to change direction and move up. So that is a minimum value. Is the graph moving left or right? Because it's x minus 3, which we did the opposite, positive 3, that means it's moving 3 to the right. And when we moved that vertex, instead of starting at the origin, where the original parent function does, it is at the point 3, 0 because it moved to the right 3 spots. So, is it going to move up or down? Well, right here we said plus 0, which means we did not move up or down at all. So now I'm going to show you a quick little trick, and if you are actually listening to the video instead of just pausing it and writing it when it is all done, you are about to receive an amazing hint that will make your life easy. Once you have that vertex, we're going to use a 1, 3, 5 ratio. Here's what that means. You put your pencil on the vertex, and you rise 1, run 1, and you get a new point. From that point, you're going to rise 3 and run 1, and get the next point. And from there, you can rise 5, run 1, and get another point. Now we can go the opposite way, go back to the vertex, rise 1, but run to the left, 1, rise 3, and then to the left, 1, rise 5, to the left, or up, and then to the left, 1. And we have a very accurate parabola simply by using a 1, 3, 5 ratio. That works because a is 1. It was 1x squared. If it had been something different, like y equals 3x squared, we would have to change that ratio to 3, 9, and 15. But we'll talk about that later. So if you're listening to the video, you just learned something pretty exciting about a 1-3-5 ratio that works for every parabola. Our domain should be pretty easy. Goes left to right, negative infinity to positive infinity. The domain goes as low as 0 and as high as forever. We are down to one more example. As soon as you are ready, go ahead and move on. This is in vertex form again, which means we can steal the vertex. We're going to take the opposite of the -3, which is +3, and then we're going to steal the constant on the end. The vertex occurs at the point 3, 5. Now, it is going to be a positive x squared, so that means it is opening up. If you were listening to the last slide, the 1-3-5 ratio, we're going to rise 1, run 1, rise 3, run 1, go back to the vertex, do it again, rise 3, run 1 to the left, rise 5, run 1 to the left. We now have a very nice looking parabola using that 1-3-5 ratio. Is that vertex a minimum or a maximum? It is a minimum because that's as low as the graph went. Now, how did that vertex form change? Well, the original parent function has the vertex at the origin 0, 0. We moved to the right 3, and we moved up 5 from the original parent function. So if you visually want to see it, we moved to the right 3, and we moved up 5 to get to the new vertex based on vertex form. The domain, again, is negative infinity to positive infinity, and the range goes as low as 5 and as high as forever. So for those of you who actually paid attention and listened to the video, you now have the super easy way of graphing your parabolas. Once you are done with that problem, you are good to go with your notes.